Under the sea.
Under the sea. We really planned this.
I would like to introduce
FAU-GEM.
Hello and welcome to another episode of FAU-GEM. I'm Vivi and I'm your today's host, and next to me is
Gönlüm, hello.
And today we're gonna talk about something, who would have guessed, ocean related.
And before we dive into details, I want to present you our program schedule. First, we will introduce the team to you, and then we will talk about the problem they addressed, and then the project introduction. And finally, a new section where we discuss related projects of iGEM. And now, Vivi can introduce the team to you.
Yeah, thank you very much, Gönlüm, for giving us that nice overview about our order again. As I said, today's team has to do something with the ocean, or at least they had a very close relation or inspiration for doing something with the ocean. So the name is also inspired by it, and the project is called Netlantis. The team is an overgraduate grand prize winner from the year of 2022 and won the prize for the best conservation project. It's a team of the University of Copenhagen, so the team name is UCopenhagen in Denmark. The team consists of 9 students from various disciplines and from 7 different countries, actually. Most of them are master students, with one exception. I guess they have one bachelor student in there, and so far so good. That's the team introduction. I think we can now talk a bit about the problem they wanted to address. So, Gönlüm, I have a question for you. Can you give me just a wild guess? What do you think is like, or which things could be a trigger for marine pollution, or could it affect marine pollution?
There is only one answer to that, and it's humans in general.
Yeah.
But if you want to go more in detail, I guess, like from my city, I know the poor waste management is very harming the water. But besides that, the oil spillages from ships and also fishing.
Yeah, you're completely right, Gönlüm. And that is actually the problem they addressed here. So fishing industry is huge. And if I say huge, I mean huge. So like in 2020, the market value of the fishing industry was $276.5 billion US dollars. It's crazy.
It is crazy.
It is crazy. And so you could imagine that they really much contribute to aquatic pollution. And especially the fishing nets are like a main topic here. As you maybe know, there is like a spot which is called like the huge Pacific or Grand Pacific garbage patch. And this is like a place in the ocean where all of the trash from all over the world comes together and build up. And this garbage patch is like 3 times the size of France. I mean, it's huge and it's crazy. Like, how did it go there so fast? And 43% of this whole patch consists of fishing nets. And I think this is really dramatic. And the team which we are talking about here has the same thinking about that. And not just that fishing nets cause a lot of pollution, they can also be a real danger to marine creatures. Gönlüm can tell you a bit about that.
Yeah, I guess there is this term, well known for the public audience, is ghost nets. They are the nets lost in the sea. And sometimes they trap the marine animals and cause the direct death of them.
Yeah, and not just that they cause death, but it's like really severe because they often got tangled or trapped like somewhere on the ground and can't move anymore. So they really starve and then die because of that. And not just that you could imagine that fish got trapped, but also dolphins and crabs on the ground. And at the same time, it is also a danger for corals, because if it got like
Covers the coral.
yeah, it covers the corals, and therefore the absorption of sunlight is, for example, dampened, and the corals die. And also they got more illnesses, because plastics in general are a very good surface for microorganisms. And Gönlüm, could you imagine another problem which is caused by plastics in the ocean?
Yeah, I mean, these nets don't stay as is forever. They are broken down into little particles which form microplastics.
Yeah, and microplastics are actually a huge discussion topic during the last years. Microplastic pollution is actually a problem for sea creatures, because, as I said, as those particles can be a surface for microorganisms, and the fish take them, for example, up by just breathing or eating, they can really cause illnesses in those fish. But for human beings, it's right now under huge discussion. So there's not a real fact that it is a problem for human beings or for the tissue, but there are some problems which are addressed by the researchers.
And there is a huge gap between the period of use of fish nets until they are completely dissolved.
Yeah, because actually plastic is, or nylon or PVC, what they're made of, is a long-lived material and takes around 400 to 600 years to be decomposed. Okay then, but what do you think, Gönlüm, would be the solution for such a problem?
Biodegradable fibers.
Yeah, and how could we achieve that is the question. And
Synthetic biology.
Yes, and that is exactly what our iGEM team dealt with here, to create biodegradable fibers out of natural resources. And we will now introduce the project to you a bit.
What I like about this project is that their approach to this problem in nature is inspired by nature.
Yeah, that is actually really cool. And for almost, here is it, like for almost everything, nature has always the most effective and simple solutions for each problem. And this time, our main actor is the spider. Yes, you heard right, the spider. And the idea behind that is to use the silk of those spiders to create fishing nets, which are highly durable, elastic, and also of tensile strength. Because this is all of the criteria silk in nature has, and therefore is a huge inspiration for using it in the fishing industry. But now you would come up with the question how to use it underwater, because have you ever seen a spider creating nets under the water? Gönlüm?
I haven't.
Yeah, but actually there are a few species doing that, and two of them are Argyronata aquatica, which is in the freshwater, and Desis marina in the marine environment. And those were the inspiration for the team.
There were other biodegradable materials suggested for fishnet use before, but they were not near comparable to plastics. And what is good about this project is that they are improving the previous designs with synthetic biology.
Yeah, and now the question is, how did they achieve that? Like, how did they construct a fiber or fibers out of spider silk? But first of all, we have to talk a bit about what spider silk in general is and where it comes from. So actually, on the bottom of the spider, there are some special glands which produce proteins, which are called spidroins. And there are actually a lot of types of spidroins. So the spider has different types of spidroins for different purposes. So there's, for example, one which is doing the slack lines, and another one which could be used in between to make it more elastic. So there are different types of them, and with different properties, you could say. And what the team now wanted to do is to create spirodines, which could be then connected to each other and make a very strong and durable material for fishing nets. So what they did, or what could be used for creating such nets, is a tool which is already known for a few years, and this is a production of those spirodines within an E. coli strain. These proteins they produced are called mini spirodines, and they were produced using Golden Gate cloning in a specific strain, which is the BL21DE strain of E. coli.
And for your information, BL21 strain consists of competent cells which are suitable for high-level T7 expression of recombinant proteins.
Yeah, and this leads to a high-level protein expression. Using this technique, they could design several proteins which can then be spun together in a fiber. And the main proteins they focused on for the core of the fiber were the spider silk proteins, which were three different kinds: the mini spidorin 2 repeats, the mini spidorin 4 repeats, and one which is called maki, which is a really new invented marine mini spidorin. And to make it even more stable, they also used a protein which is naturally found in anemone, and to be more precise, in the nematocysts of the tentacles, and it's normally used for hunting prey. And the name of this protein is aneroin. And with all of those components, they formed then the core fiber. And this core fiber is then coated in another protein. And this protein is found where?
On muscles.
Yes, actually. It is part of the biceps or located at the biceps of a muscle, and is therefore called muscle foot protein. And those muscle foot proteins are characterized by their stickiness. And because they are so sticky, they serve as a perfect protection from degradation by proteases and bacteria. And also they make the fibers more durable and stronger. But somehow now this core element, or the core fibers, have to be connected to each other and also connected to the sticky surface of the muscle foot proteins. But how is that achieved?
They used a technique called snoop tug and snoop catcher. It is a lock and key system that links two different proteins.
Yeah, and how do they do it? Like, how is it done?
And one protein is merged with snoop tag, and the other protein is merged with snoop catcher. And catcher always finds the tag.
Exactly, because it's a spontaneous isopeptide bond, which is formed between the tag and the catcher, and therefore it makes a very strong and elastic fiber.
To make the long story short, this can be the future of fishing industry.
I think you're completely right here, and it is really a promising approach to tackle the problem of marine pollution in an efficient manner.
And with that, we are at the final part of today's podcast, where we discuss the other iGEM projects related to that topic.
Yeah, so we will talk a bit about spider silk projects of the last years. And actually, it's crazy what you can do with spider silk. So the field is really huge, and a few teams addressed that already in the past, which is, for example, the team of Edinburgh in 2019, and they used spider silk as an alternative to synthetic textiles. So this could really be then an alternative for synthetic fibers, and would revolutionize the textile industry and the clothing industry.
Yeah, also another team from Vienna last year, they developed building materials by using spider silk, gelatin, and BHB.
This is also a fantastic idea to contribute with all the materials used up in construction fields.
Exactly.
Really nice. I love it. And a team from Switzerland, also in the year of 2002, addressed a project called Hestia, and where they used spider silk for constructing sustainable insulation material. As we know, like insulation materials in housing and so on is often also built up out of glass, or so glass wool, for example, or synthetics, and this could also make then building of houses more environmental friendly.
Exactly.
So if you're more interested into one of those topics, you can of course read into their wikis also for the Netlantis project. If you're more interested, just go to their wiki and give them like, I don't know, a read through. And I think, yeah.
This is it for today from us. Thank you for listening.
Thank you for sticking to us till the end. And yeah, we wish you the best. Stay tuned.
And curious.